Now we are going to discussing about rotenone structure, and that is structural determination of rotenone. And the rotenone molecular formula is C23H22 and O6, and its double bond equivalence is here number of carbon atoms are 23 and number of hydrogens are 22 and divided by 2 plus 1. We know the double bond equivalence formula. According to this, number of carbon atoms are 23 and number of hydrogens are 22 and plus 1. If we are calculating this, we get 13, right? The double bond equivalence for the rotenone structure is 13. And now second one, that is reduction. If rotenone undergo reduction, there is a dihydrorotenone formation will be takes place. That means here when rotenone reacts with this H2 platinum, this catalytic hydrogenation takes place to form dihydrorotenone, which indicates that there is a one double bond present in the rotenone structure. See here, this is the rotenone structure. When we undergo treated with H2 platinum, then the double bond will be removed or vanished, and it will get a dihydrorotenone structure. Next one is Jessel method. We know that already we discussed about Jessel method. Jessel method is used to identify the number of methoxy group present in the molecule or structure. So Jessel method is used to identify number of methoxy groups. Here the rotenone will be treated with HI to form 2-methyl iodide, to form 2 moles of 2-methyl iodide, and which undergo reaction with AgNO3 to form AgI precipitate, which these 2 moles will indicate that in rotenone structure will have 2 methoxy group. See, the rotenone structure will have how many moles here? How many moles of methyl iodide will be formed? 2 moles. The 2 moles which indicates that there is a 2 methoxy group present in the rotenone structure. Okay, this is the rotenone structure, and it will have 2 methoxy groups. Right. Next, the test for carbonyl. We know that when the rotenone structure will react, rotenone will react with hydroxylamine to form oxime. That means when carbonyl compounds are present, then only the oximes will react with the carbonyl compound to form oximes. So here we conclude that the rotenone will have one carbonyl group. The rotenone structure will have one carbonyl group. That's why it will be reacts with hydroxyl ammonium to form oximes like structure. Okay, and finally the rotenone structure will react with zinc dust to form two types of structures, that is rotenol and diritol. Okay, rotenol and diritol structure. Okay, these two forms will indicate that rotenone will have 5 cyclics, means 5 cycles, 1 2 3 4 5. This when we treated with zinc dust to form rotenol and diritol structures, these two structures will indicate that rotenone will have 5 cycles. Here 1 2, and it will be cleavage of this bond will be takes place to form OH bond, that is nothing but here OL alcohol kabatti it OH, this is nothing but hydroxy or alcohol, here OL, which in the bond cleaved here, so form these two structures, and we can conclude that rotenone will have 5 cycles. And the rotenone is a odorless and colorless crystalline insecticide, and it is a naturally occurring in the seeds and stems of seedy plants, some stems of several plants, such as jicama is the jicama jicama plant mainly occur in the rotenone compounds. Okay, rotenone is a odorless and colorless crystalline insecticide, and it is available in Jamaica vine plant. Okay, rotenone will be available in Jamaica vine plant. This is the structural determination of rotenone. Now we are going to discussing about how the rotenone structure will be synthesized. Here, synthesis of rotenone. Here, this is the 2-hydroxy. Here, this is the carbonyl group. This is the functional group. 1 2 3 4 5. 2-hydroxy 4, 5 dimethoxy benzaldehyde. This is the 4, 5 4 comma 5 dimethoxy 2 hydroxy benzaldehyde, and it will be treated with ethyl bromo acetate. This is the ethyl bromo acetate. Then the it will be formation will be like this. Here the well, oxygen electrons comes here and bromine and HBr will be removed. So here the formation will be like this, and it which are treated with here epuric acid. Just will repeat epuric acid. This is the here epuric acid. It will be reacts with epuric acid. Here NH. This is NH. Okay. Epuric acid. This is the CH2 group, and the H2 and O will be combined to form removal as a water molecule to form formation like this. Okay, the structure will be formed when we this one reacts with epuric acid to form like this molecule, and which one treated with which will be formation here. See here, when these two when the electrons on nitrogen will be shifted to here, then the double bond will be moved to here, O minus again it will be moved to here. Then removal of OH will be takes place, and this H and this OH minus will combine removal as water. Then structure will be, and it will be formed like this. And when in presence of base only it will be happen. And base in presence of base there is a loss of proton takes place, and the structure will be like this. And when we treat this one treated with OH minus, the OH minus will be attack, and this carbon atom and this bond will be shifted, and this bond also shifted. Whereas here see there is a loss of here N, there is a loss of C, there is a loss of CPH, here PH is there, and C triple bond N. Okay, there is a loss of Ca phenyl C nitriles will be loss of nitriles will be takes place here, and then the structure will be formed like this. Okay, here loss O minus will be takes place, and H will be attracted on this carbon this oxygen to form OH and here acid group. Okay, this OH will be attack on this carbon, so it will be OH, and it converted a acid, and it will undergo ketoenol tautomerism. This is the enol form. It will be keto form. So it is a ketoenol tautomerism, and this one reacts with hydroxylamine. What we are from it? When we treated with hydroxylamine, then it will be form a axam structure. These are the axams, and it will be converted as a, see here, it will be converted when the OH will be shifted to here, and this bond moves to here. Okay, this bond moves to here, and this OH will be removed. So this one combined to form, when we are heating, this acid group will be removed as this carbon dioxide, and this H and the OH will be combined as a water. So finally the compound formed like this. We have taken this one as a fragment ion 1. Okay, this is a fragment 1. Okay, in the same way this compound reacts with HCl in presence of ZnCl2. This is a Gutterman reaction, and Gutterman reaction nothing but is a formylation reaction takes place on the benzene ring. So this compound will treated with this reagent, that is HCN in presence of ZnCl2. Then formylation takes place in the aromatic ring. Here the formylation of the molecule will be takes place here, and this are treated with this bromoacetate in presence of weak base. This one treated with bromoacetate in presence of weak base. Then the loss of proton takes place here, and this OH minus will be attacked on this carbon atom. Removal of bromine will be takes place, that is nothing but HBr removal takes place, and formation of the molecule will be like this. Okay, formation of the molecule will be takes place, and this one treated with base means there is a loss of proton. Here loss of proton takes place, here OH minus, this will attack on this carbon atom, and it will be OH minus, and this can be converted as a like this. When this OH minus and H remove takes place, there is a double bond will be there. Here this is the product will be like this, and and we are undergo hydrolysis. When hydrolysis takes place, the esters will be esters can be hydrolysis to form acids, and when we are eating the acid, then there is a loss of CO2 takes place to form this type of molecule. Okay, there is a loss of this this total compound will be vanished because when we when we undergo hydrolysis, the ester compound will be converted to the acid compound, and when we are eating, then loss of CO2 takes place, so this molecule will be formed. Okay, and next here double bond is there. Okay, and next it will be this one treated with methyl magnesium bromide, that is nothing but a Grignard's reagent. This methyl minus will be reacted on this carbon atom, and OH minus will take place, and here OH minus, and this is the methyl group. Okay, and this one undergo catalytic hydrogenation, means there is a here double bond is there. When we are doing catalytic hydrogenation, then the double bond will be removed. Okay, that is fragment 2. In the same here, first fragment, and this is the fragment 1 and this is the fragment 2. When fragment 1 and fragment 2 combine together in presence of ZnCl to HCl, this is the same. This is just like in Gutterman reaction, there is a formation of aldehyde will be takes place. Okay, here formation of aldehyde will be takes place. Now this I am writing first here. So these two are in presence of ZnCl to HCl. This is the HCN, like HCN compound. So here a formulation of the reaction takes place, that is nothing but Gutterman reaction. So first I will writing here this one C double bond O. Here this will be converted as a C double bond O, and here carbon atom, this carbon atom, and the total structure will be here. And this one undergo reaction with bromine. This will reacts with bromine. See here next bromine, there is a loss of OH takes place, and attack of bromine will be takes place here. Okay, in the same way the CH3 can be C here, and CH3 can be written as the CH2 and H. Then H will be here, come here, and bromine will be takes loss of bromine takes place, that is nothing but a minus HBr takes place, and the compound converted as a, like this is the olefin molecule will be takes place here. And next, in presence of sodium state, there is a loss of proton takes place, and here negative charge will be there, and this negative charge will attract, and this carbonyl, this ester come, this is C double bond over there na. This the O minus sorry, the negative ion will be carbon ion will attack on this carbon atom, then loss of C O ethanol will be takes place, and then this molecule will be converted is a like this. Okay, I will be writing the proper structure. I see here, and this carbon. Okay, this carbon, right, this carbon will be attacking this carbon atom, so I will write this carbon joining this, and this carbon will have a double bond O, so this double bond O. And next here this double bond O, and this is the again carbon atom, this is the carbon atom, and O, and it will be attached to this aromatic ring, this will be attached to aromatic ring. Okay, next the OH minus, the OH is there now, so the lone pair electron oxygen will be attacking this carbon atom, and the double bond moves to here, and it will be converted as a this molecule. Okay, then the H and the H will be the H and OH minus will be removed like a water to form a double bond. And when we are doing catalytic hydrogenation, that is controlled catalytic hydrogenation in presence, that is H2 in presence of palladium carbide, because gives rise to, this is the final structure of rotenone structure. Okay, this is the final structure of rotenone. Thank you.